Carbon monoxide, CO, contains a triple bond between the atoms of carbon and oxygen, one of which includes a coordinate covalent bond. How can the bonding in CO be shown using a dot and cross diagram? Only include the valence electrons. We need to create a dot and cross diagram for carbon monoxide, but we don't have a lot of space to do that with all of these answer choices on screen. So let's get those off the screen. Carbon monoxide has a triple carbon-oxygen bond. We're told one of these bonds is a coordinate covalent bond. In a covalent bond, a pair of electrons is shared between two nonmetal atoms. In a regular covalent bond, each atom donates one electron to form the bond. But in a coordinate covalent bond, both electrons in the bond come from one of the atoms. With that in mind, let's create the dot and cross diagram for carbon monoxide. We'll start off with two overlapping circles, one for the carbon atom and one for the oxygen atom. Next, we'll fill in the diagram with valence electrons, using them to create the bonds in the molecule. Carbon has 4 valence electrons, and oxygen has 6 valence electrons. We'll represent carbon's valence electrons with a blue cross, and oxygen's valence electrons with a blue dot. So this is how we can show a regular covalent bond between carbon and oxygen. Carbon and oxygen both donate a valence electron to form a regular covalent bond. There's 2 more bonds between carbon and oxygen. One is another regular covalent bond, and the other is a coordinate covalent bond. Oxygen has 2 more valence electrons than carbon does. Those 2 extra valence electrons will be used to form the coordinate covalent bond. With the 3 bonds formed between carbon and oxygen, both atoms have 2 electrons remaining. These remaining electrons will be used to create lone pairs, filling the valence shell for both atoms. Now we've finished our dot and cross diagram, so we can compare what we've created to the answer choices. We can see that the bonding in carbon monoxide, including the coordinate covalent bond, can be shown using a dot and cross diagram that matches answer choice E.